Alright, so now looking at problem number 9. So again, we're just evaluating functions like we've done before. We're going to go and plug in. So I'm finding g of 3. So I'm going to take my function here. And wherever I see an x, I'm going to replace it by 3. So that gives me the square root of 6 minus 6, which is the square root of 0. And that's just equal to 0. Now let's do 4. So doing the same thing, but now we're replacing the x value by 4. So that's going to give me the square root of 6 minus 8. That's square root of negative 2. Well, that's not good. That's undefined. And again, it's undefined. The real numbers, we will see later, we'll be able to continue working with it when we get into solving quadratic equations and get into imaginary and complex numbers. And for this one, we're going to plug in the negative 4. That's going to give me a 6 plus 8. That's square root of 14. Now, in ALEKS, they will want this written exactly that way. They don't want you to go and get a decimal approximation. They'll just want you to put in the square root of 14. Let's practice some more graphing. So I'm going to determine the domain and range of a function. So again, given a relation defining y as a function of x, the domain is a set of all x values in the function. The range is a set of all y values in the function. So we're going to look at the picture. And again, you literally want to think about it like you're squishing the graph here to get my range, squishing the graph here to get my domain. These arrows means it goes on forever, so when I squish this thing down, I'm going to get a line here that extends on forever in both directions. So if I'm looking at this, my domain here is going to be from negative infinity to positive infinity. Now if I squish this one this way, this is going to flatten out here starting at 2, but then it's going to go over forever. And it actually hits the number 2, so my range here is going to be 2 comma infinity with a square bracket around 2. Remember, I'm not going to do the value at 1 here. I got to do the y values when I'm doing the range. All right, let's try this one. This one's really goofy looking. So let's kind of think about this. This thing here is extending on forever this way. I do have a jump, but if that x value is filled in down here, so that's good. And then this extends forever this way, which means it's also going on forever this way. So if I were to squish this down for my domain, I would end up getting something that would look like this. And if I were to squish this whole thing down, just flatten it down. It's kind of hard to see. Let me do it with pens. So if I were to squish this together, that would give me the x-axis. So my domain here is going to be all real numbers. The range is good. It's kind of goofy here. This thing goes on forever here, but it kind of bottoms out here at negative 10. So again, if I were to take this and squish this until onto the y-axis, it would start at negative 10 and go on forever. And you need to go from bottom to top, lowest to highest. So starting at the bottom would be negative 10. Let me put that in green. So if we flatten it out, it's going to look something like that. So it's going to start at -10, and it's going to go to infinity. Sorry about that. We're having we're having some rough weather. We'll just say that as I'm recording this. So I forgot to put my phone on vibrate. My apologies. Let's move on to number 12. All right. So in terms of my domain, this extends on forever. I do get that point included there, but then if I flatten this out, again, flattening it out vertically, going from, flattening out horizontally, I can't speak today. Flatten this out, I'm going to get something here that extends on forever here, but it's going to stop here at 4. So flattening it out, I'm going to get something that looks like this. So that'd be from -infinity to 4. Now the range is really weird. So let's take it piece by piece. So now I'm squishing in this way. If I squish this part here until it's flattened out, I'm going to get something that looks like this. And in fact, let's do this. Since those are filled in dots, let's just put some square brackets on there. So my interval will be from 2 to 8, including 2 to 8 for that piece. But then I have this little value down here at 1. That's just a single value. So in mathematics, when we want to say we can either be here or here, we use what's called a union symbol. Looks like the letter U. U for union. All right, let's try this next one. So again, if I'm flattening this out to get my domain, my x values are starting at -2. This arrow means it goes on forever. Well, it's going to continue out this way too. So it's going to go from -2 to positive infinity. It's a filled in dot, so I'm going to put -2 to positive infinity. Now, since this arrow goes down on forever, for my range, I've got -infinity all the way down here, and then it's going to top out here at 4. So remember, domain left to right for domain, range bottom to top. Range is bottom to top. All right, let's turn the page. Okay, so now we need to head back to page 14 of our workbook. And we need to talk about the last part here. If we're given y equals f of x equals 3x minus 12 and find f of 3, that means we replace x by 3 and solve for f of x. In other words, if we're given x, we need to find y. If we are given a graph of g and asked to find g of 2, then we need to find the point on the graph that has an x-coordinate of 2 and determine the y-coordinate to get the answer. So if the graph, the function, passes through the point 2, -8, we just read off the y-coordinate to get our answer. G of 2 would equal -8. Now suppose we said to find all x for which f of x equals negative 9. Now we are given y and we need to find x. If our function was f of x equals 3x minus 12, we would then set the 3x minus 12 equal to negative 9 and solve for x. The answer would end up being 1. If we're given a graph of g of x and asked to find all x for which g of x equals 4, we need to find the point on the graph, and there may be more than one, that has a y-coordinate of 4 and determine the x-coordinate to get our answer. So if the graph of the function passes through the point negative 7 comma 4, then the answer would be negative 7. So now we're ready to flip back to page 17. And we've got this funky looking graph. We want to use the graph of y equals f of x to determine or to answer the following. So here I'm looking for f of negative 3. So I'm given x was negative 3. I want to find that point and read off the corresponding y value. So that's this point here. To be negative 3. And the y value is also negative 3. So my answer here would be negative 3. All right, let's find f of 0. So when x equals 0, that's this point here. That's the point 0, comma 2. So when x equals 0, see if I can make that better comma, my y value is going to be 2. Now I'm looking at f of positive 3. That's this point here. That's 3 comma, looks like about 2.5. So I'm just reading off the y value. The y value is 2.5. And then f of negative 1, well, it's not that point. It's got to be this point here. It's negative 1 comma negative 1. So that's equal to negative 1. So this is given x, find y. So I'm looking at all the points that have these x values and reading off the y value to get my answer. All right, so next we want to find all x for which f of x equals negative 1. So now I want to look for all the y values that are equal to negative 1. Well, the only place that occurs is here. So my answer here would be negative 1. So my set here would be the point negative 1. Then I want to find all the x values for which f of x equals positive 1. Well, that only spot occurs here. That's the point 2 comma negative 1, so that's going to be the set 2. G says determine the x-intercept. Well, does that intersect the x-axis? Nope. So there is none. All right, determine the y-intercept. Well, it hits the y-axis here at 0, 2. So 0, comma 2 would be my y-intercept. All right, let's do the domain. So if I were to take this and squish it down with that arrow there, I would hit the entire x-axis. So my domain is going to be all real numbers. And now we want to determine the range. Range is going to be pretty goofy here because I've got this gap. Now this open circle is filled in with that one, but I don't get anything in between. So I'm going to get two parts to my range when I squish this in. I'm going to get a part going down here and a part going up here. Now I have to write it from smallest to largest, bottom to top. So I'm going to go from negative infinity to negative 1. So let's write that down. I got this other part. I don't include 1 here, but I do include the 1 here. So this goes 1 to positive infinity. And then I'm going to put my union symbol. And that will be our answer.